Hello and welcome to another Thinking Particles tutorial video. In this video we will show you how to create these mechanical 7-segment display effects. Okay, let's do this. Let's try to reproduce what we saw in the introduction animation. But before we do so, let me just bring in the background and the idea of this animation and what we wanted to achieve. I was always fascinated by 7-segment displays. Let me just bring in this web page. So that's just a random web page that explains digital segments and how to address them and how to use them. So you find them, just search for 7-segment displays and you will find all kinds of information about them. Usually they are just LEDs and you turn these LEDs on and off, and there's 7 segments and sometimes there's a dot as well. So it depends on the display, and you can display numbers between 0 and 9. And then obviously you need to have some kind of table where you say, okay, my 0 looks like this, my 1 looks like this, my 2 looks like this. So you decide which one of these segments you turn on and off. That's actually it. And usually this turning on and off is done by electronics that just tell you, okay, we want to turn it on and off and supply power to the LED, and then it lights up, and then we turn off the LED. However, these are the old side and they're cool. I love these LED segments and displays. However, there's one thing that's even cooler than the LED, old style LED displays. There's things, let me just bring in another description of a type of segment display. And those are mechanical ones. And they're not that common. However, they are really present in gas pumps and all kinds of industrial displays where you have to have a robust and reliable method of display. And these mechanical displays, they're really funny. They are just made out of a magnetic system. So you have little magnets behind and they just pivot away. So that means these little white segments, they just tilt inwards and then they disappear from the display, and that's how they display the numbers. And here you can see that they have these magnets. You turn them on and then they just tilt away and come back. And this is all set up so that it is just really a magnetic field. These are on little pivots and with a magnet in there. And then you have the outside electromagnets, and then it tilts away and in and out. So it's really fascinating that you still have this kind of mechanical displays. But they have some advantages. So they work with, for the display itself, they don't need to be illuminated. So there's no lamps, there's no issues when the LED doesn't work anymore. So this thing is just by indirect lighting. So you shine light on it, and this is a little bit of a bright or reflective surface. You will see this, and you can see it from far away, and they're immensely robust. So that's kind of really interesting. And if you wanted to see this kind of thing opened up, you can see these mechanical displays here and how they are working. So it's kind of really funny to have these kind of displays. And here you can see the tilting away. So they just tilt away, and you have this little angle here so that they can hide on the side of this display. So I wanted to reproduce this kind of display. Keep in mind that my 3D Studio Max scene is not working like that because I was thinking of, hey, let's do something different and invent something new and use some different technology. So not the magnetic tilting mechanism. I wanted to go for a servo motor, and servo motors, in contrast to stepper motors, they allow you to really fast switch an angle. So you give it an angle and put power on it, and it switches to a specific angle in an instant. So these kind of, that's the idea, to tilt away my segments. So I built this object here, which is a pretty simple setup. So I have my surface, my segment. That's just a white surface. And I built my little servo motor here that just works and rotates. So when I go, for example, let's have a look here, and I'll just use the actuator 01. And when I animate this here, I can just rotate, let me just zoom in, my segment in all directions. So that's the idea. So we flip this away, and then we would have a casing around, and then these white fields just disappear to the side. And this is how we can display our numbers. So how would I now control which number to display? And because this is a Thinking Particles tutorial, I suggest we use Thinking Particles for it. So the important part is, and that's what we already or tried to show, is these are segments. So we have to somehow decide which segment is responsible for which area of the number. So what I did here is very simple. I started numbering here. So that's my segment 1 or 0. We start with 0. 0, 1, 2, 3, 4, 5, 6. And remember, I started at 0. So yes, it's still 7 segments. So we count from 0, 1, 2, 3, 4, 5, 6. So that's how I defined it. You can define it however you want, but that's how I defined the segments. And then I have all these 7 actuators. As you can see, from 0 to 6, I have these actuators, and they can all tilt in various directions. So let me just show you this actuator. Let me just do this full screen. So this can tilt away. So we have all these segments here, these actuators. So now let me just show you how cool and easy this is to get into Thinking Particles. Let me bring in the Thinking Particles user interface. So all I'm going to do right now is select my actuators. I'm going to do that. I'm just selecting these actuators by clicking on the pick option on our object to particle, and I'm going to use the select by name dialog. Let me just move that over here, and here we have the select by name dialog, and I'm just going to select from 0 to 6 my 7 actuators. Just say click. So we got them in. All I need to do now is changes affect all. I need to go to particle to object, and I'm going to explain why we're using this option. And I need to make sure that our actuator particle group is selected as well. So now that I've done this, we should be good and fine with our 7 segment display. Let me just move that out of the way for you, and let me just play back this. So we can see it's already working. It's counting and showing us numbers and displays, and we can see all is working as we expected. They're tilting, rotating away, and we can all see this nice effect. This is somehow magically working right now, and I'm going to explain step by step what we actually did here. However, I'm going to do even one more thing, because we're talking here about a procedural system we built with thinking particles. I'll just remove all my actuators right now. So now we have no more actuators. So we are back to square one, so to say. Let me just move that away. When we now animate, nothing happens. As we can see here, nothing happens. So we have removed all actuators. But what I'm going to do now, let me just switch the screen. What I'm going to do right now is I'll select all my objects, hold the Shift key, as you know, the standard 3D Studio Max function, and move that here. I'll want probably instances, and I'll move that here. And I'll probably want instances as well. So now we have a lot of actuators, because we have 3 displays right now. Let me just give it a little more space here so it looks much nicer. So now we have a lot of actuators. Let's see if that works as well. So I'm just going back to my object to particle, pick. Again, I'm choosing the select by name dialog, bring up the select by name dialog, and now I'm picking all the actuators I can grab. So now I'm picking all the actuators. We are doing the same thing. We need to make sure changes affects all, particle to object, and we want to go into the actuators group. So now I have all actuators in thinking particles. When I go one step back and forth, we will see that something magically is happening. So 1, 2, 5, 1, 2, 5. Let me play back. 185, 185. Let me play a little bit more. 245. And so on. You get the idea. So somehow, magically, we get our frame number here on our display. How did we do this magic trick? How can it be that I just create one display, 7-segment display, just instance it, and it works? And that's the beauty of thinking particles. It's the fully 100% procedural approach. So once you have set up everything, so the segments are numbered in a correct order or in a defined order. It doesn't mean correct. I said you can define it however you want. So I started, as I mentioned before, I start with my counting 0, 1, 2, 3, 4, 5, and 6. These are my 7 segments. However, you can count however you want. As long as you know which is which, you can adjust it as you want. So now let's have a look into the actual magic that's going on with thinking particles. How do we rotate our little servo or actuators? How do we do that? And there's one simple dynamic set, and that looks like this. So that's all the magic that happens. It can't be easier than that. 2 simple nodes. The first node is my time base. Time base node is just spitting out a time. That's all, or the frame. So when I go to 1, it spits out 1. When I go to whatever, 78, I get 78 as a number here. And we have an input number where I just feed in the number. And now the beauty is I can make this slower even or faster, so we can make it count much slower. Let's say I only want my real time to be 5% here. So now the time passes much slower. So now we can see it's counting much slower. Just stop that. So that's a really nice feature. I can say, okay, I just want speed reduction 10% of the speed, and now we are counting faster. So now if I want to see my elements much better, we have one control here, the fold speed. I could reduce the fold speed. So now my elements would take much longer to open up. So I can follow these little actuators and display the animation like that. And just with this little bit or few settings we have here, we can already do amazing work. And this is all possible because Thinking Particles is a fully 100% procedural system. So you set up your nodes. Once a system works, it always works. Regardless if you have one display or 100 displays, if you change the input amount, it's independent of anything. It will just work. So let's have a look at the real magic going on with our little expression MEL. And I know some of you might moan and complain right now, oh, scripting, oh, no. But that's the real power. If you want to do advanced visual effects in 3D Studio Max and beat the crap out of all the other studios out there that use some other magic or magician tools, you have to look into that. There's no way around. But we created MEL in such a powerful and easy way. It's just a few lines of code and everyone can do it and everyone can learn it. So let me just bring up our editor here. And this is the code. I have a lot of explanations written there. So we will go through it step by step, and I will explain what's going on here and why this is working as we just saw. The first thing we are doing here is defining our inputs. So let me just move that side to side. I'm just moving that here, and here's our code. So I define an input group, and that's a particle group. And I selected a particle group here, our actuators. So that's the first important step. How does my script get the information of my actuators in the scene? That's just a simple particle. So we got the particle in. Let me just switch to the other dynamic set. We got the particles, or we turned our actuators into particles with an object to particle. And we're using the particle to object option. And I know not many have used this option, or you might even don't know that it exists at all, because the main option is object to particle and that's it. But what we are doing is the particle to object does the other way around. So a Thinking Particles particle is actually animating from the outside, from the Thinking Particle side, a 3D Studio Max mesh or object in the scene. So now we are just manipulating a 3D Studio Max object in the scene. So from the outside, we can now control rotation or whatever position and anything we want. We are controlling with Thinking Particles a 3D Studio Max mesh. So that's why we have chosen this option. I want to rotate the max object in the max scene and not the other way around. I want to bring everything in the Thinking Particles and do it in Thinking Particles. And this has the advantage that we can have motion blur, as you might have seen in our introduction animation. So let's go back to our MEL expression. I'll just move that over here. So we have a particle. So we can access now in Thinking Particles our actuators, our particle, which is a simple particle, that's all. The next thing is we create an input for our number. There we have the number. And this is grayed out because we specify the number with the time base. That just gives us the frame slider number here as input. And we can, as I showed you, manipulate this as well. So that's the thing we did with the input for the number. And we have an input for our folding speed. because we might want to animate or show how our actuators actually rotate and move these segments in and out. The next thing we are doing here, so these are our inputs, we are creating a virtual input, so to say, or just a memory holder or a memory space. So we are creating a memory with a variable rotation. So now it's just a scalar value. So we have a variable rotation that we can access at any point in any dynamic set. So now we have a variable rotation declared. The next thing is I just create an up vector. So I have to do some work with the rotation. So I need to know where's up and where's down and where's left and where's right. So my up vector is just a simple z-axis or z-axis. So that's x, y, z. And the z-axis points up. That's my up vector. Done. So now I know when I use this vector or this variable, I know where it's up. Or that's my reference for any calculation I will do with this up vector. So the next thing we are doing is we are saying when a particle is born, and again, particle in this case means our actuators. We bring in these particles that control our max objects. So when one of these actuators is actually created, we are setting our initial state. So as I mentioned, we have our variable declared here, rotation. So we can access now the variable directly. So PID is our particle ID, PID. So this particle that is just created, so let's say it creates our first actuator, I will store in the rotation an angle of 90 degrees. So that's my start or initial value. That's my, as I mentioned, we just store that. And then I'll set the alignment to represent these 90 degrees based on my up vector, because I need to calculate where's up, and then I can calculate 90 degrees left, right, up, down, and so on. And in this case, all segments look up. That's my initial situation, and all segments are visible or on, let's say, with on and off. The next line is very simple and basic as well. I have a variable that's called digit. And by digit here, I mean I want to know, is this the ones, tens, and hundreds digit? So that's the ones, tens, hundreds. Also very simple, 0, 1, and 2. 2 would be my hundreds position in the digits. And I calculate everything based on my segments, because we know every display has 7 segments. We can easily differentiate when I have to do a switch between, because we can count from 0 to 9, and when we are going to 10, I need to switch to the next display. So when we have 9 here and we go actually to 10, I have to put a 0 here and a 1 here. So when I want to switch to the other display, I'm just calculating here, get me the next display or segment. So digit just gives me 0, 1, 2. So this calculation is floor and divided by 7 based on the particle ID, the particle that is actually processed right now. It just gives me a 0, 1, 2. So now I know which position I am with this variable. So digit holds my actually display 0, display 1, display 2. The next variable I create and calculate here is our segment. And the segments are these little LED displays, or in this case, we have mechanical displays we want to move in and out. And the segment I can get from the particle ID, so particle 0, 1 or actuator 0, 1, 2, 3, 4, 5. Every actuator we see here with this servo I built here, every actuator, there's 7. I can easily get with a modulo math calculation. So that will just give me the segment number. Is it segment 1, 2, 3, 4? So I always get from in the segment, I always get the numbers between segment 1, 2, 3, 4, or 0, 1, 2, 3, 4, and so on. I did here some adjustments for the viewport. We don't need that if we are going to render, but for now, for the viewport, I did these little adjustments here. The next thing is we are calculating the numbers, the actual numbers we get. So for the number calculation, we use our number in. That's the input we get. So if we get, let's say, 300, we need to decide where is our hundreds, the 3, and where is our 0, and so on, or 2 and 1. So this is just the 10-digit switch. So in our system, we switch from as I said, 9, 10, we need to switch 1 over, and then we have the 1 here and the 0 here. So that is giving us, just based on the number in, we calculate, okay, what's the position and number value. So here we just declare another variable where we use a flag. And here comes the segment numbering, where we say we turn on and off the segments. So as I mentioned, the number in calculation gives us, we have a number of 0. We need to turn off on all these segments. And as I mentioned, let's pick an easy number. If we get calculation here, we have to display the number 1. So if the number in is equal to 1, we are switching on 0 and 1. And I told you that I calculated 0, 1, 2, 3, 4, 5. And I don't mention here the flags for 2, 3, 4, 5, 6. So that means I'm only switching on 0 and 1. 0 and 1, and that will give me a 1, or the number 1 in a display. And by this, I can create all kinds of numbers I want. Let's take another simple number, number 7. So if we get from our calculation up here, hey, we have to display a number 7, I'm just going here and I'll turn on segment 5. So 0, 1, 2, 3, 4, 5. I'll turn on this segment. I'll turn on segment 0. I'll turn on this segment. So now we have these two on. And I'll turn on segment 1. So that gives us the number 7. Turning on this, 5, 1, 0, and 1. So now I have the number 7. So I think you get the idea about these flags. And these are just bit flags. So we have this function in MEL, and you can easily look this up with the flag set and just press the shelp button. And that will give you the description of what the flags do and how you call the function of flags. You can set and clear flags and test flags and so on. So it's very easy to follow this tutorial. Just press the selective help button and you get information about the functions we use here. So now I set into this variable, I said this needs to be switched on, and these flags are set for our number. The next thing is really straightforward as well. We have a new variable where we say our angle, we call that grad, and we get from our memory the rotation We do some calculation with our folding speed. We don't want to jump right away to 90 degrees to turn it off or switch it off our display. We want to give it some time. So we have a multiplier here, and we give it a little bit of a random value as well, so that we can have different fold speeds for each segment. And then we just test the flags, which one is on. So if we know, okay, we have to turn a segment, we are going to turn the segment 90 degrees with our calculated folding speed and all the steps. Then we set the alignment here. So we rotate it and we remember which rotation we did. And that's actually it. So that's a case when we have to flip it. And here, if we don't have to flip it, we just keep the segment as is. And that's it. Simple, short script. So now we can do everything we want. Very simple setup. We have full control. And the beauty of it, as I mentioned, and let me just repeat it because it's a really powerful function. Not many setups use the particle to object option. But the beauty of these particle to object option is actually that we can create or manipulate 3D Studio objects. So what we see here is when we have an animation going on, this rotation, we are actually rotating a 3D Studio Max object. That's a 3D Studio Max object. It has its own controller on it, and thinkingParticles is remotely controlling it. And the beauty about that is we have then a normal Max object, and every renderer can grab the motion blur, for example. So we get really nice, beautiful motion blur for our objects that move or are manipulated with thinkingParticles. And that's all we have here. So one node to bring in our actuators and create particles out of it. Let me just, we have the ticks turned on, and let me just show you that we actually have particles. Let me just hide all the objects. And there, oh, I missed some of the actuators. But there you see we have for each actuator, these little boxes that rotate, we have a particle here. And that is what we are processing. So each of the actuators creates a particle in thinkingParticles, and we're doing all the manipulation and magic with bringing in these actuators and turning them into particles, and then we can access them here in our melt script in parallel, because our first input here is the actuator's particles. So we go through all the particles here in parallel. So we are processing them really fast and very efficient. So we get the particles in here, and then we can access the particles. We get the particle ID, we get the orientation, we can set the alignment, and all the other manipulations we did here is to decide which segment is turned on and off. So 2 simple nodes, little bit of thinking. That's why we named our product thinkingParticles. It doesn't mean it thinks for you. No, you have to do also a little bit of thinking, but then you have all the freedom and the power to do fully procedural animations. And you don't have to be afraid if there's a change, no problem at all. If you need more digits or more displays, you just add them as I showed you, no problem at all. And you have full control over how fast they rotate, everything you want, and you can just go into the MEL script and manipulate the hell out of it. That concludes my tutorial here with the mechanical 7-segment displays. I hope you enjoyed this tutorial. I for sure did. And please make sure to check out our other tutorial videos as well. Thank you for watching, and goodbye.